you. Good afternoon. My name is Sara Deslauriers, and today I'll be presenting the findings from the data collection that I collected this summer during my internship in Rouge National Urban Park about the effects of forest characteristics and landscape configuration on flying squirrel populations. So urban and peri-urban environments present challenges to conservation biology as landscapes are transformed to accommodate rapid expanding urban development. Forest habitat is destroyed and then remaining patches become isolated, decreasing habitat connectivity, and with it decreasing the probability of successful wildlife dispersal. This presents a particular conservation challenge to arboreal or tree-dwelling species who rely on certain forest characteristics in particular. The response of species populations to habitat loss and fragmentation depends on a variety of factors, but primarily the configuration of the remaining landscape features, and most importantly, the quality of remaining habitat, fragment size, and the proximity between patches. Among forest small mammals, flying squirrels are of particular study interest in a landscape fragmentation context. As forest obligates, they are highly sensitive to habitat loss as they depend on trees, not just for nesting and food, but as their primary source of locomotion. However, their dispersal capacity might be heightened because of their gliding capacity when we compare them with other similar sized mammals. Flying squirrels can also serve as potential flagship species in the Greater Toronto Area because as nocturnal gliding mammals, well, they're adorable and people love them. And their presence or absence from a stand can also be essentially a sentinel for changes to forest configuration or structure. They also play a very important functional ecosystem role by eating hypogeous fungi and then dispersing the spores throughout the forest, as well as serving as a key food source for avian predators such as the endangered spotted owl. Both southern and northern flying squirrels are forest obligates, and they prefer mature forest stands, with northern flying squirrels preferring intact conifer forest and southern flying squirrels preferring intact deciduous forest with large mass-producing trees. Both species in Canada are currently vulnerable to population decline, with northern flying squirrels experiencing loss of primary conifer habitat due to logging and forest conversion in northern Canada, and then southern flying squirrels experiencing northward range expansion due to urbanization and climate effects. From the Mammal Atlas of Ontario, we can get an idea of the species range. For example, we know that northerns have previously been found in and around Rouge, but we don't have any data available now on where they currently are. And we don't have any idea either of where, or a good idea of where southern flying squirrels are located, especially around the Rouge watershed. So this is why Rouge National Urban Park, which is located in Scarborough, so at the east end of the Greater Toronto Area, is an excellent study site because it allows us to sample mature forest patches within a spectrum of urban and peri-urban environments. So to give a brief overview of the landscape metrics that were assessed for this project, first we focused on patch size, which is the size of an individual forest fragment. So if you think about loss of habitat from development or logging, this is going to reduce the overall size of habitat. And then this reduced patch size will in turn increase the likelihood of local population extinction. This is because a reduction in patch size is going to reduce the carrying capacity of that patch, and it can support less individuals of a given species. So for example, for flying squirrels who are social nesters, this is a problem because they huddle together for thermal regulation over winter. And if a patch size is too small, then it's going to fail to accommodate enough individuals to prevent this. Secondly, we're going to talk about actual habitat connectivity, which is the degree of connection or isolation of a forest patch from neighboring patches. So if a forest fragment is too heavily isolated from other patches, it really reduces the likelihood that any given individual could immigrate to or colonize a neighboring patch. So in this sense, the distance and the landscape matrix surrounding a fragment is really crucial to determining successful species dispersal because, for example, flying squirrels as forest obligates will very rarely venture out into a non-treed matrix because this puts them at increased risk of avian predation and exposure. So we know that patch size is a very important correlate for flying squirrel abundance and occurrence. This study that was done by Patterson and Malcolm in Ontario showed that With increased patch area, you're going to have an increase in the abundance of northern flying squirrels. And they were also able to establish a patch size threshold of 29 hectares, below which no flying squirrels were found. And we also have some indications that connectivity is an important correlate for flying squirrels. So the study that was done by Smith et al. In New Brunswick translocated northern flying squirrels at varying distances over a non-treed gap. And they found that as gap distance increased, the probability that the flying squirrel would actually make its way back to their treed home decreased. And they actually found that there was a very steep cutoff at about 350 meters, above which it was almost impossible for the squirrels to return home successfully. So first thing that we wanted to find out with this study is, what is the distribution? Where are flying squirrels located within Rouge National Urban Park? We also wanted to explore their abundance over a variety of different sites. And to explore the distribution and abundance, we considered two key factors. First, the site level habitat characteristics. So the individual tree species, the basal area, snag density, and basal area of coniferous and deciduous trees, among other predictor variables. And we also looked at landscape configuration metrics, so patch size and connectivity. Based on the previous studies that we had seen, we predicted that patches that were less than 29 hectares would negatively impact flying squirrel population persistence, unless these patches were connected by less than 350 meter of space between neighboring patches. So we used this metapopulation model that Jay produced, and this is based on existing literature of how populations might respond to varying habitat characteristics, patch sizes, and degrees of connectivity. We then picked our sites in Rouge Park based on this metapopulation modeling that had at least a reasonable chance that we would find flying squirrels there. So on the right is a map of our study area. So this is Rouge National Urban Park. And the points that you see are the 19 sample sites that we used for our small mammal trapping and our habitat sampling throughout May through August of this year. So this in green is an excerpt of the map that you just saw. So this is one of our sites. As you can see, we set up a 4x6 trapping grid with 40 meter spacing in between. So we had a total of 24 traps per site and a total of 19 sites. So that was 456 different trapping areas that we had. So for our small mammal capturing, we use the large Sherman trap that you see that we temporarily affixed to a tree. We set the traps for 3 consecutive nights, rebaiting them with bedding, apple slices, peanut butter, and sunflower seeds. When we check the traps, if we did come across a mammal capture, we would first identify the species. If it was a flying squirrel, we could also identify or record the sex, the weight, the reproductive status, and attach a numbered ear tag. If it was any other species besides a flying squirrel, we would simply record the species and let it go. We also performed habitat sampling at half of our trap sites. That means 12 out of every 24 stations at our 19 sites. We used a basal area factor of 2 prism to perform prism sweeps, and we recorded data on the trees that were at least 10 centimeters diameter of breast height. So we recorded the DBH, the tree species, and if it was a snag, then we would record the decay class and the large major group, either coniferous or deciduous. So for the results of our small mammal distribution, as you can see, we caught 7 different types of mammals, but these were all basically anticipated bycatch based on the what we were filling the traps with and the size of trap that we were using. So as you can see, for example, a white-footed mouse was the most prevalent in terms of distribution. It was located at 18 of our 19 sites. And you can see that our flying squirrels, for example, southern flying squirrel was only found at 6 out of our 19 sites, and northern flying squirrel was found at 7 out of our 19 sites. In terms of abundance, no surprise that red squirrel and eastern chipmunk were extremely abundant in most of the sites that we sampled. And then we found the southern flying squirrel had an average of 1.84 individuals per site, and northern flying squirrel had an average of 0.68 individuals per site, which is also kind of funny because northern flying squirrels were found at more sites, but with lower occurrence or lower abundance. We also performed a stepwise Poisson regression model to test each of our mammal species against our tree species and habitat predictor variables. So while we found no significant correlation for northern flying squirrels with these habitat characteristics, we did find important significant findings for southern flying squirrels. So if you can see here on the rainbow matrix on the left, this is actually the number of squirrels captured at each site. So there are 19 dots on this graph. And you can see, for example, the topmost point, this is where at a station where we caught, or a site where we caught 8 individuals. And it happened to be a site that had extremely high percentage of sugar maple trees and also a very high overall basal area of deciduous trees, which basically proves what we already know, that southern flying squirrels prefer habitat that's deciduous forest with large mass-producing trees. We then performed another Poisson regression model using our landscape metrics. So patch area first, we found that northern flying squirrel was not significantly correlated with patch size, but that southern flying squirrel really was. So on the right here, this is the southern flying squirrel chart. And if you see here, this is essentially every site ranked by the area of the site. And this purple line is the abundance of southern flying squirrels that we found. So you can see that southern flying squirrels really preferred sites with a larger patch area. And then this green line down here is northern flying squirrels. And you can see that they're a bit more generalist, that patch size wasn't as important to them, although the abundance was a little more skewed to larger patch area. And this red line down the middle is the threshold of 29 hectares that we had talked about earlier. And we actually did end up finding, contrarily to the Patterson and Malcolm study, that at our sampled sites, we were able to find both northern and southern flying squirrels in patches that were less than 29 hectares. We then tested the mammal correlation with habitat connectivity. So for both northern and southern flying squirrels, habitat connectivity was an important correlate. And as you can see here, southern flying squirrel was much more abundant in sites that had a very high connectivity in meters between the patches, whereas again, northern flying squirrel were more generalist, so they were much less affected by degree of connectivity between patches. And then the red line up here is that 350 meter gap crossing metric, or yes, that we talked about earlier. And essentially what we found is that not a single one of our patches that we tested was actually exceeded 350 meters of isolation. So we set out to gain some insight on the distribution of northern and southern flying squirrels, and we discovered that both species are relatively widespread. In addition to that, we recorded the first data on southern flying squirrels in Rouge Park. Second, we want to investigate habitat characteristics, but these were pretty much in line with what we already anticipated, with northern being more conifer lover and southern being much more deciduous lover. We also wanted to learn about landscape configuration effects, and we did indeed find fragmentation effects. We found that the degree of habitat connectivity had an impact on flying squirrel occurrence, as both species were found in greater abundance of fragments with the highest proximity to other forest patches. However, patch size was not a significant correlate for either species. And this could be because Rouge Park seems to be quite well connected in terms of its forest fragments. So small patches can, in that instance, maintain a self-sufficient population as long as there's enough connectivity between the patches. And this is contrary to the Patterson and Malcolm study where, below a certain threshold, they didn't find any flying squirrels, but that's because there was a much, much higher degree of isolation for each patch in question. This also means that flying squirrels are a good indicator species to help guide landscape configuration. And also as a management implication for Rouge Park, well, they can really just continue to maintain the amount of habitat connectivity that they have and improve it, because it does seem to be promoting successful flying squirrel population establishment now and hopefully into the future as well. I'd just like to thank Jay Malcolm for all his help with trapping and fieldwork and the knowledge behind the study and the modeling. Thank you to my field partner, Leah, this summer, and also to Leonardo Cabrera of Parks Canada for the opportunity to conduct this research in Rouge. Thank you very much.
Thank you. And I'll pass the virtual microphone to Leonardo for the first round of questions.
Thank you very much, Sara. This was a really good presentation. Lots of hard work. I remember seeing you with all these traps, and yeah, really good work. What would you say about how healthy are the populations of these flying squirrels compared to potentially other numbers of abundance? I remember you presented low numbers like 1 or -1 individuals in your areas. How healthy these numbers can be compared to other sites?
Well, compared to the other species that we sampled, I'd say that they're probably about average. I mean, not having seen too many other studies that compare specifically flying squirrel abundance with the abundance of other mammal species of similar size. But when you consider that flying squirrels are much more sensitive to habitat loss and fragmentation than, for example, eastern chipmunk or red squirrel, I would say that it is normal that we would find less of them just in general. But again, I haven't seen a study that, or I haven't personally read a study that compares too many flying squirrel abundance with these particular other species that had been collected.
Can I ask a second question?
Absolutely.
As Parks Canada representative, what would you tell us in terms of future recommendation, future research?
Yeah, I would say that as we've seen that patch size is a bit less important than habitat connectivity, and that with the current amount of habitat connectivity in Rouge, that they are able to sustain populations in quite a few of the fragments that we studied. I would say that maybe the utilization of wildlife corridors, just to, for example, look at a map and see where we could be improving the connection between patches. So if we see a few patches that are in close proximity to another, but that the population of flying squirrels is absent from that other patch, then we could do something to potentially improve the connection between them. I would say probably one of the biggest dispersal barriers between forest fragments is maybe just the roads that we saw. For example, our site below the 401, well, it was devoid of any flying squirrels. But I'd say it might be harder to make some sort of wildlife corridor that crosses the 401 to allow for flying squirrel dispersal. But yeah, I would say mostly just focusing on improving habitat connectivity between the existing patches where we know the populations are already thriving.
Wonderful. Thank you so much, Sara.
Thank you, Leonardo.
Other questions? I'm going to come back to Jay here.
Well done, Sara. Yay.
Thanks, Jay.
Remember where you weren't there, actually, we were out in Rouge with the newest MFC class and looking at some forest restoration sites and actually planting some trees there. And generally speaking, my impression and what they talked about was that their restoration site selection is very opportunistic, where they have maybe some forest nearby to build on, and they have a landowner that says, yeah, I'm interested. Do you think that Rouge should try to move into a sort of another mode in that they actually target, their restoration activities to really focus on connectivity?
Yes. Short answer, yes, that would seem ideal. I guess the question is that in Rouge, a lot of it is federal park area, but then there's a lot of it that's individual landowner or private property. So I guess it would be trying to find some combination between appeasing the ecological restoration that we want to do and also not stepping on the toes of the private landowners who are there. Because I remember just anecdotally, while we were sampling some sites, just parking our truck, we would have people come out and asking like, what are you doing here? You're in my backyard. Which we weren't in their backyard, but
We weren't in any backyard.
no, we were just closest to their area. So I would understand why they would take an opportunistic approach, that if they have a chance for restoration in an area, they're going to take it, because even if it's not necessarily improving habitat connectivity, it could possibly promote a patch area that would be large enough to introduce, for example, flying squirrels or other mammal species.
What about the idea of putting up dispersal poles for flying squirrels? You think that's something worth investigating?
Yeah, I think so. I think it's really cute. So flying squirrels have been known to traverse gaps of like 30 meters, pretty, I'd say, with relative ease. So if you have an area of like two forest patches that are separated by a road, which is, more narrow than 30 meters, I would say that it's definitely a good possibility. Or it would be a good opportunity. Yeah, it's been done semi-successfully in the States. I can't remember where they did it, but there was a study in the States where they did set it up over a roadway, and it was working semi-successfully. So.
Hey, Sarah, great presentation. I'm just wondering, in your opinion, like all things considered, what does the future of flying squirrels look like in Rouge Park? And if I were to go observe these squirrels, what would your advice be? Like,
I didn't hear the second part.
Hello? Yeah, if I were to go observe these squirrels in Rouge Park or wanted to, what would your advice be to go? Like, where would you go? What time of day?
Great questions. Well, I think the future looks pretty bright, actually, considering that whereas we had known historically that northern flying squirrels may have been around Rouge, now we've been able to prove conclusively that northern and southern flying squirrels are able to establish a thriving population there. And we're going to end up seeing more and more range overlap between these two species as northern flying squirrels are kind of pushed to the southern end of their extent because of loss of primary conifer forest, and then southern flying squirrels are pushed to the northern end range of their extent, northern end extent of their range because of climate effects. So I think we're going to just end up seeing more and more in this in this pocket right here in southern Ontario. If you wanted to go see them, I would say you're going to need some pretty good night vision goggles. So they're nocturnal, they're mostly active. We did some camera trapping as well, and the footage showed that they were most active between 1 and 3 a.m. So that would be a good time to go. Try to find a good forest patch. I can show you the map if you like. But yeah, maybe have some truffles on you or some peanut butter, because they did like that. Yeah.
Any other questions? Field advice, maybe? For those online, Jay is sharing stories of having flying squirrels eating in his hands with sunflowers. Well, if there are no more questions, thank you very much, Sarah.
Thank you.